Hi, this is Dane Quinn from the University of Akron, and for today's video lecture, I'd like to give a quick introduction to velocity. So what is velocity? Well, it's the derivative of position. It describes how the position of a point changes over time. Right? So over here on the right, I've shown a point P at two different instants in time. Right? So this is kind of the initial time, and then this is some later time. Right? So we take the initial time and increment it by very small value delta t. So here we'll denote this position vector as r of p with respect to o. And this is at time t, right? So r of p with respect to o is again the position of p with respect to o. So o here is the origin. Now, one thing that's important is that the origin is fixed in what we consider to be the ground frame of reference. So you can think about it as the plane of the paper or your computer screen, but in particular, it's not moving, and it serves as our reference frame. So the origin is fixed in the ground. Then we have, again, this position vector written at a new time. So that's p with respect to o at time t plus delta t. The displacement of p would be given by this vector, right, from the initial time to the final time. And we would define that as delta r of p from time t to time t plus delta t. And then we're going to define the velocity as the derivative of this vector. So kind of going back to the definition of what a derivative is, it's the limit as delta t goes to 0 of the displacement. All right, so that's going to be the position at the final time, t plus delta t, minus the position at the initial time, time t, divided by delta t. Right? Or again, it's the limit as delta t goes to 0 of the displacement with respect to time. So delta r of p from t to t plus delta t divided by delta t. So we define this then as the derivative of p with respect to o. So the derivative of the position. And again, the velocity is the change in the position. So these vector derivatives, and of course the position is a vector, right? So we're looking at derivatives of vectors, account for change in both magnitude, but as well as direction. So if this vector p with respect to o got longer, then the velocity of p would be non-zero. But even if this vector stayed the same length, but was now rotating, then p would also have a velocity. So again, vector derivatives deal with change in both magnitude and direction. Right? So again, here I've kind of given a point P that's moving along a path. So when we look at the velocity, we find that the velocity is tangent to the path of P. So here, if I have a point P and I calculate the velocity, it would actually be in this direction because this is the tangent direction to the path. Right, so here the velocity of p at some time t, and this would be the position of p at time t, is defined as the derivative of the position. Right, so again, the velocity is the derivative of position. If at this earlier time, say I went and determined the velocity, I'd get something that was, kind of in this direction, right? Because this is the direction that is tangent to the path. And then we find that the speed is the magnitude of velocity. Here, the speed of p, and notice that this is a scalar quantity, is defined as the magnitude of the velocity of p. And here, the velocity is a vector. Again, the speed is a scalar. So we've seen the relationship now between position and velocity. And just kind of as a pictorial representation, if I want to go from position to velocity, I take a derivative or differentiation. Will take us from position to velocity. Likewise, if I want to start with velocity and get back to position, well, you can probably guess what this would be. This would be integration. So if I integrated the velocity, I could determine the position of a point. So again, integration velocity, or integration and differentiation, allow us to move between position and velocity. So again, this is a really quick lecture just on sort of what velocity is. In order to really calculate velocities, we have to start talking about vector derivatives and actually how to calculate them above and beyond sort of the standard calculus definition, which involves that limit process. So that'll be the next lecture. But again, I just wanted to give a quick introduction to what velocity means for us. So that's it. Thanks a lot, and I will talk to you again soon. Bye.